In 2008, Russian archaeologists found a tiny finger bone in a cave in Siberia. It was so small they almost threw it away. But DNA analysis revealed something shocking. The bone belonged to a species of human that science didn't know existed. Not Homo sapiens, not Neanderthals, something else, something we now call Denisovans. We know almost nothing about them. We have 3 teeth, 1 finger bone, and some skull fragments. That's it. Yet, genetic evidence shows they lived across Asia for hundreds of thousands of years. They interbred with modern humans. And if you're of Asian descent, you probably carry their DNA right now. Today, we are going to explore one of the greatest mysteries in human evolution. Who were the Denisovans? Let me start with the discovery. Denisova Cave in southern Siberia has been excavated for decades. Archaeologists found stone tools and animal bones dating back hundreds of thousands of years. But in 2008, they found something different. A small piece of finger bone from a child. They sent it for DNA analysis, expecting it to be Neanderthal or modern human. The DNA came back as neither. It was similar to both, but distinct from either. They had discovered a new branch of the human family tree. The child who owned that finger lived about 50,000 years ago, but the DNA showed that Denisovans as a species existed for much longer. They split from Neanderthals about 400,000 years ago. They spread across Asia, while Neanderthals spread across Europe and the Middle East. Here's what makes this remarkable. We discovered an entire human species from a single finger bone. Everything we know about Denisovans comes from tiny fragments of bone and teeth. We have never found a complete skeleton. We don't know what they look like. We can only guess at their culture and behavior. Yet genetic analysis tells us they were widespread. Denisovan DNA has been found in modern humans from Tibet to Australia to the Philippines. They must have occupied a huge geographic range. They lived in diverse environments, from cold Siberian mountains to tropical Southeast Asian islands. The 3 teeth we have are strange. They're much larger than modern human or Neanderthal teeth. Massive molars that suggest either a diet requiring heavy chewing or simply different jaw and tooth proportions. Without more bones, we can't tell if Denisovans were larger overall or just had big teeth. Scientists tried to reconstruct what Denisovans might have looked like using DNA analysis. They found genes for dark skin, brown hair, and brown eyes. But these are just guesses based on genetic markers. We don't know their height, body build, or facial features. One clue comes from a partial skull found in the cave in 2019. It's thick and robust, more so than modern humans. This suggests Denisovans might have been stockier and more heavily built. But one skull fragment is not enough to know for sure. Here's where it gets more interesting. Genetic evidence shows Denisovans interbred with modern humans, multiple times, in different places. This means they encountered Homo sapiens as our ancestors spread out of Africa, and they didn't just fight or avoid each other, they had children together. Modern humans of Asian descent carry between 3 to 5% Denisovan DNA. That's significant. It means your ancestors met Denisovans and formed relationships with them. The genetic mixing happened at least twice, possibly more times in different regions. Some populations have more Denisovan DNA than others. People from Papua New Guinea and Aboriginal Australians have the most, around 5%. Tibetans have specific Denisovan genes that help them survive at high altitude. Han Chinese have some Denisovan ancestry. Native Americans have a small amount. The high-altitude adaptation is particularly fascinating. Denisovans gave Tibetans a gene variant called EPAS1 that helps their bodies use oxygen efficiently in thin air. This gene is rare in other populations but common in Tibetans. Without this Denisovan contribution, humans might have had much more difficulty settling the Tibetan plateau. This tells us Denisovans were already adapted to high altitudes. They must have lived in mountainous regions for long enough to evolve these adaptations. Then when they interbred with modern humans, they passed on this survival advantage. But Denisovan DNA also shows up in island populations of Southeast Asia. How did Denisovans get to islands? Did they have boats? Could they navigate open ocean? These questions have no answers yet. The presence of their DNA in island populations suggests either impressive seafaring abilities or now submerged land bridges. The timing of Denisovan interbreeding with humans is also puzzling. Some genetic evidence suggests it happened as recently as 15,000 years ago in Southeast Asia. If true, Denisovans survived much later than we thought. They might have coexisted with modern humans for tens of thousands of years. Here's something that will blow your mind. Genetic analysis shows that Denisovans themselves interbred with other mysterious human species. There's DNA in Denisovan genomes that doesn't match any known human species. This means there were at least 4 types of humans living at the same time: modern humans, Neanderthals, Denisovans, and something else we haven't identified yet. We're learning that human evolution was not a simple line from primitive to modern. It was a complex web of different human species that split apart, lived separately for hundreds of thousands of years, then came back together and interbred. The Denisovans were part of this web. What the Denisovan culture look like? We barely know. The cave in Siberia contains stone tools, but we can't be certain Denisovans made them. Modern humans and Neanderthals also lived in that cave at different times. The tools could belong to any of them. One tantalizing discovery is a stone bracelet found in the cave. It's made from chloratolite, a stone that requires sophisticated drilling and polishing. If Denisovans made it, they had advanced crafting skills. But again, we can't prove who made it. The cave also contains evidence of fire use, bone needles, and worked ivory. Someone was doing complex tasks there. Were these Denisovans or the other species that lived in the cave? Without definitive evidence, we're guessing. What we do know is that Denisovans survived in harsh environments. Denisova Cave is cold and remote. Winters are brutal. Whatever humans lived there needed sophisticated survival skills, fire control, and probably clothing and shelter construction. The fact that Denisovans left so little fossil evidence is itself a mystery. They lived for hundreds of thousands of years across a vast area. Where are all the bones? Why have we found so few remains? Several explanations exist. Maybe they lived in small populations that didn't leave many fossils. Maybe they lived in regions where bones don't preserve well. Maybe we found Denisovan bones, but didn't recognize them because we didn't have DNA to test them against. There's also the possibility that we have found Denisovan remains but classified them as something else. Before DNA analysis, anthropologists categorized fossils based on physical features. Unusual bones were sometimes put in vague categories or labeled as archaic humans. Some of those might be Denisovans. Recent discoveries support this. In 2019, a jawbone found in Tibet decades ago was tested and identified as Denisovan. It had been sitting in a museum unrecognized. How many other Denisovan bones are sitting in collections waiting to be tested? The Denisovan mystery also raises questions about how many other human species existed that we don't know about. DNA can only be recovered from bones that are not too old and not too degraded. Older remains might have lost all recoverable DNA. We might be missing entire branches of the human family tree. Africa presents a particular mystery. Modern humans evolved in Africa. Neanderthals and Denisovans evolved outside Africa. But were there other human species in Africa that we don't know about? Genetic analysis of modern African populations shows some mysterious ancestry that doesn't match known species. This suggests there were ghost populations of humans in Africa that interbred with modern humans before going extinct. We don't have fossils. We don't have names for them. We only see their genetic shadow in modern DNA. The Denisovans might be one of several mystery human species we're only beginning to discover through genetics. As DNA analysis improves and we test more fossils, we might find more branches of the human family tree. What happened to the Denisovans? Why did they go extinct? We don't know. They survived for hundreds of thousands of years but disappeared sometime before 15,000 years ago, possibly earlier. Competition with modern humans is one possibility. Climate change is another. Or maybe they didn't go extinct. Maybe they were absorbed into the modern human population through interbreeding. If enough Denisovans interbred with modern humans, they might have essentially merged with us rather than dying out. Their genes survive in millions of people alive today. In that sense, they're not extinct. They're part of us. This is true for Neanderthals too. Most non-African people carry 1 to 2% Neanderthal DNA. Combined with Denisovan DNA in Asians, many modern humans are actually hybrid populations. We're not pure Homo sapiens. We're a mix of several human species. This has implications for how we think about what it means to be human. The boundaries between species are not as clear as we thought. Different human species could produce fertile offspring together. They were different, but not that different. It also means that the abilities and traits that make humans successful might have come from multiple species. Some of our immune genes come from Neanderthals and Denisovans. Some of our cold adaptation comes from them. Some of our high-altitude adaptation comes from Denisovans specifically. We didn't develop all our advantages alone. We inherited some from our extinct relatives. In a real sense, Neanderthals and Denisovans are our ancestors, not just evolutionary cousins. Their legacy is written in our DNA. The Denisovan story is still being written. Every year brings new discoveries. More fossils are being tested. More genetic analysis is revealing details about their lives and relationships. We might find a complete Denisovan skeleton someday. We might discover they had unique abilities or cultural achievements. Or we might never know much more than we do now. Sometimes in science, mysteries remain mysteries. We have to accept that the past is not fully recoverable. The Denisovans might always be shadows, known more through their genetic legacy than through fossils or artifacts. But even as shadows, they're important. They remind us that human history is more complex than simple narratives suggest. They show us that we're connected to the past in unexpected ways. They prove that there were other forms of humanity that lived, loved, and passed on their genes to us. If you carry Denisovan DNA, you have part of a mystery species inside you. Genes that evolved in humans you'll never see. Adaptations that help them survive challenges we don't fully understand. They're extinct as a separate species, but they live on in you. If this journey into the mystery of the Denisovans made you wonder about your own ancestry and the humans we've lost to time, hit that like button and subscribe. We're exploring the hidden chapters of human history and the species that made us who we are. Ring the notification bell so you don't miss our next investigation into the mysteries of human evolution. Drop a comment if you've done DNA testing and carry Denisovan ancestry. You're carrying living evidence of a species that science barely knows exists.